Hey guys, here we are with 8.4, graphing rational functions. So a rational function is an equation of the form f of x equals a of x over b of x, where a of x and b of x are their own polynomial functions. So you got a lot of stuff on top, not necessarily a lot, but you're going to have functions on the top and the bottom. You're going to have stuff on the top and the bottom. Sometimes it's nice and short, sometimes they get a little lengthy. And then, of course, you can't have the bottom equal 0. When the bottom does equal 0, that would be a vertical asymptote. It's just so the function would not be defined at that point. Horizontal asymptotes. Okay, things to watch out for here. If the degree of the top is bigger than the degree of the bottom, then there is not a horizontal asymptote. So if the top is, say, like x to the third plus whatever, and the bottom is like x plus whatever, okay, the top is bigger, x to the third is going to have a higher degree than x, there will not be a horizontal asymptote. Okay, if the top is smaller, that will force your asymptote to be at 0. So if we have x to the third plus whatever over x plus whatever, okay, this x to the third, oh, I went the wrong way, didn't I? Other way around. We got regular x on the top plus like 2 over x to the third plus x squared plus x plus 1. Okay, so this x to the third is going to get really big really quick. And this is going to still get big, right, as we go off to infinity, but this is getting much bigger, much quicker. So you're going to be dividing something up here by something really big, and when you divide by something really big, your answer is really small. So that's going to pull it down to 0. So when the bottom has a bigger degree, then your asymptote's going to be 0. Top is bigger, no horizontal asymptote. Bottom is bigger, horizontal asymptote at 0. If they tie, you got x squared plus 3 over 3x squared minus 1. They tied. They're both x squared. Now you look at the coefficients on those x squareds. 2/3. So my horizontal is at 2/3. So if they're tied, then you look at their leading coefficients and divide those. Okay? Oblique is a slant asymptote. We're just on an awareness level of that right now. An awareness level of that. That you could have a diagonal or a slanted asymptote. You just need to know what it's called for our purposes right now. And what that would look like is if we have like a crazy graph, and it's going to be like this, and it's going to kind of go out like that, and this one's like this, and comes sideways like that, and you can kind of see where you would have a diagonal asymptote there. Okay, you just got to know that they exist. Point of discontinuity, aka sometimes this is called the hole. Looks like a hole in the graph due to the function being undefined at that point. That comes from where your asymptote would have been factored out and canceled. So here's my original equation, my original function, x squared minus 4 over x minus 2. So I'm looking at that like, ooh, vertical asymptote at 2, but we factor out the top, and look what happens. Cancel, cancel. All right, so now we're down to just this, x plus 2. That's a line. And instead of having our asymptote at 2, we're just going to have a hole in the graph. Okay, and we'll talk more about that when we get to one. Okay, we just have a hole in the graph, an open circle there. Because that point's not defined. It's defined here in our simplified one, but it would not be defined in our original equation that we're given. All right, let's do one. x squared minus 2 over x squared minus 1. Okay, so first thing I'm noticing is x squared, that's a tie. Alright, that's a tie. So we're going to have a horizontal asymptote at 1 over 1. Our horizontal asymptote is going to be at 1. Because of our degrees tied, like number 3 here. So we compared the leading coefficients. My leading coefficients are 1s, so 1 over 1 is going to be 1. Okay, on the bottom, I bet we're thinking, okay, it's going to have 1 at 1, but also this is a difference of squares. So really across the bottom we have this, x plus 1, x minus 1. Okay, sneaky with that. So we're going to have a vertical at 1 from this one. We also have a vertical at negative 1 from that one. Okay, we should probably write these down. X equals negative 1, x equals positive 1, y equals positive 1. Okay, so we have all our first stuff down here. Alright, so here's what I have. On my graph, I have something from a different problem, and the scales are all messed up. So if you need to get back to like the normal stuff, zoom, standard, zoom 6 puts me right back on the negative 10 to 10, negative 10 to 10. I still need to type in the right equation, but I just thought I'd show you that real quick. So there's stuff on the top and the bottom, so you got to use a lot of parentheses here. We got parentheses, x squared minus 2, close them, divide by parentheses, x squared minus 1, close it, graph, boom, boom, boom. Alright, so kind of fits. I mean, this is really weird over here when we have the 2 verticals, so there's 3 sections, so we're going to have 3 branches. And again, we're just going to do the best we can. So let's go, I guess, left to right. This is negative 1. What about negative 2? Oh, I didn't push trace. Got to push trace first. Trace. Negative 2. Negative 2, comma 0.6 repeating. These are going to be small, aren't they? Not fun. Negative 1, negative 2, 0.6 repeating. Negative 3, 0.875. Okay. Can we go backwards 1, like negative 1.5? Is that going to give me a 9? Oh, there we go. That's not bad. Well, 0.2, but negative 1.5, 0.2. So nothing good. I'm running out of space to label. Remember, if it's not a perfect point, you should label. And just judging from the picture here, very steep. This is very flat and a very sharp turn and down. Okay, in the middle, so the middle, let's see, that is negative 1, so, and this is positive 1, so the only whole number in the middle there's 0, trace 0, 0, comma 2, that was nice. Alright, so what about like negative 0.5 and positive 0.5? Not very helpful, is it? 2.33 each way there. Remember, label those. On a quiz or a test, hopefully you'd have a bigger thing, a bigger coordinate plane there, more room. Positive 0.5 should be the same thing, 2.3 repeating. Okay, on this side we're going to have some more ucky ones. So 2 is 0.6 repeating. 3 is 0.875, just like the other side. Keep going, 4, 0.93 repeating. Okay. You see that's pretty sharp. And I missed them all again. Great. Alright, there you go. It doesn't say anything about domain and range. But domain, all x is not equal to negative 1 or 1. Range, let's see here. So y values that are less than 1 or greater than 2, right? We don't have or greater than 1, or it's not all y is not equal to 1, because here's 1, and then we have a gap until we start at 2 and only go up from there. So we're missing everything from 1 to up to including 2 there. Okay. Let's do another one. X to the third over x plus 2. So the top is bigger, so we're not going to have any horizontal. We're not going to have any horizontal. Okay. The bottom, x plus 2, that means we're going to have a horizontal at negative, or a vertical, excuse me, at negative 2. Okay, let's see what we got. X to the third divided by parentheses x plus 2, close them, graph. Do we have anything on the other side? Zoom out. Enter. There's got to be something down there. Oh, it's up here actually. Okay. So this is going to be a really bad graph. Let's go back to the standard. Zoom 6, zoom standard. We'll take care of this branch over here on the right side. So that asymptote is at negative 2. Let's check out negative 1. Graph. Trace. I always forget trace. Negative 1. Negative 1, negative 1. 0, 0. Positive 1.3. What about 2? Let's start to get something on the up and up here. 2, 2. That's a nice one. Is 3 a nice one? 3 is 5.4. 1, 2, 3, 4, 5. We'll call that 3, 5.4. That's good enough. Okay. And then we got a crazy piece over here somewhere. All right. It's not like it's you would have to change this the scale to be something so ridiculous that if you did the scale where both would fit, you'd just be doing that just to get this one little piece, and all these would be like super squished down, really small. So this is not the best problem. Okay, on a quiz or a test, they should all fit, but we got something going on up here. I'm not too worried about it. Okay. If we're looking at this one, again, the top is bigger, all right? So we're not going to have a horizontal. Top is bigger by 1, and that is the case when the top is bigger by 1, x squared on the top, x to the first on the bottom, so the top is bigger by a power of 1. When you're going to get that oblique or slant asymptote, again, it's just an awareness level for right now. So if we're looking at this, we're going to have a vertical at 0. We're not going to have a horizontal. Okay, then it'd be the same thing. You're just going to type it in. You would just type it in, 6x squared. You know what, we got a lot of stuff on the top. We need parentheses, don't we? Parentheses around all the stuff on the top. 6x squared minus 3x plus 2, close them, divided by x on the bottom. Since it's only one thing on the bottom, you don't need the parentheses. Maybe you like doing the parentheses. Is it going to show us anything? We're going to get the top piece. Oh, you can barely see that dot down there. We'll zoom out one time. Zoom out. Enter. Click enter again. We're just going to look at it just so you can see what the slant one would kind of look like. All right, so this is very, very steep. Remember that we have a vertical at 0. So this is going to come down, do a very sharp turn and jut straight up. And this is coming up and diagonal and very sharp turn and goes straight down. So what if I can do a little better? Let's do like negative. We can still do negative 10 to positive 10. You don't need to do this. Don't worry about messing this up. I'm just trying to get this so we can kind of see it pretty nicely without it also being so far out that you can't see what's going on, the turnaround. That's a little better. So that's what happens there with your oblique asymptote. It'd be like right there. Okay? But otherwise we're coming down and then very sharp at that vertical asymptote at 0. So, yep, just an awareness level one there. If this happened on one of your graphs, you can still graph it. You're just doing the same stuff. Trace, -1, enter, get your point. -2, enter, right? We still want to have a couple dots, 3 dots per branch, and then curve it out, just that you won't have this dotted down on your paper. You can still graph it. And you're going to have a couple problems like that in your homework, and you can still graph them, do the best you can. All right, but we're just moving on because we're already at 16 minutes. Okay. D is the same thing, another oblique one, so we're going to skip that. E is a holes one. So initially I'm like, ooh, it could be another oblique. And you can kind of compare, zoom out, Mr. Handke. You can kind of compare D and E here. It's like, oh, we're bigger by 1. Okay. We're going to have a vertical. I'm thinking right away, I got a vertical at -4. Oh, here's what happens. This is factorable. This is x plus 4 times x minus 3. Now my x plus 4's cancel out. Now I no longer have a vertical asymptote, but I'm still going to have a hole at -4. I still can't use x equals -4 because in my original equation that's a no-no. Okay? So I'm graphing x minus 3, but I can't have, x cannot be -4. Well, what would the point be? You're like, where does the hole go? What would the point be? If I did put -4 into the new equation, -4 minus 3 would be -7. So my hole is going to be at -4, -7. Should I go by 2's? Let's go by 2's. -2, -4, -2, -4, -6, -8. So at -4, -7 whole. All right. Otherwise, we're graphing like normal. X minus 3. So we're starting at -3. And we're going up 1 over 1, up 1 over 1. If we're going by 2's. All right, and there it is. You just got a hole in the graph. It's a normal line, just a hole in the graph. So if x can't equal -4, and this is just a line, what y value am I going to be skipping as well? Because it's going to, y's are going to keep going up and y's are going to keep going down. You're also not going to be able to use y equals -7 because that's where the hole was. We get where the hole was or is by what x value can I not use? Put that into the simplified equation, okay, and that's going to tell you where the hole would be from the original. Like, yes, obviously I can put -4 in here with no issues, but if I go back to the original equation, the original function, if I put -4 in, it's a no-no, right? -4 plus 4, we get 0 on the bottom, can't do that. All right? So that's why, even though it factored out, we still can't use that. And this would tell us where we're going to go. -4, -7. And so we can't be -4 or -7. Now in the homework you might get multiple points of discontinuity. You might be able to factor out the bottom and factor out 2 things that cancel. So you have 2 holes at -4 and whatever else is down there. Okay? This one, pretty close, but you can't factor. I don't think there's anything you can factor. Multiplies to 20 and adds to 8. At least you're not going to be able to use 2 with it, so that's going to end up being another one like C, another oblique asymptote. So there you go, guys. Try those out. Again, it's just a lot of where's your asymptotes go, and then now graph it on the calculator, plot some points. All right, this is kind of a thinker problem. You got to think a little bit with that one, so that might give you some trouble. Otherwise, it should be pretty smooth sailing. Thanks a lot. Let me know if you have any questions. We'll see you around.